Let W be a subspace of Rn, and let W perp, W perpendicular, be the set of all vectors orthogonal to W. Okay. Verify the three conditions to show that W perp is a subspace of Rn. So three conditions to show a subspace. Zero element should be in that space. If there are two elements u and v, then their sum should be there, and scalar multiple of a vector. If you have a constant c and a vector u, then c times u should be there as well. So these are the three conditions needed to show for W perp to be a subspace of Rn. Okay, so let's try the following. So zero vector is in W perp because if we multiply zero vector with any vector of W, so the generic vector of W, let's say lowercase w, and when we multiply means when we take the inner product or dot product with zero vector, all components 0, this will be 0, number 0, right? For any W, this element coming from W, if we take any generic element from W, vector space W, and multiply with zero vector, it's going to be 0. That means this zero vector must be in W perp. Okay, that's what we showed here. Now 2, we take two elements from W perp and show their sum is also there. Let u and v be in W perp. Okay, then by definition any element of W dot u is 0, dot v is 0. So then by definition of W perp, if we multiply u with W, because W is coming from W, u is coming from W perp, so this product must be 0. Product means inner product. And v dot W is also 0 for any or all W in W, vector W in W, because these u and v are coming from W perp. Now we need to show u plus v is also in W perp. So now let me write down now u plus v. To show u plus v is also in W perp, we take its product with generic element of vector space W, so W, and we know that this inner product is distributive, so u dot W plus v dot W, dot W, and we just saw that since u is in W perp, u dot W is 0 and 0, so we get 0. So u plus v times any generic element from vector space W is 0. That implies u plus v must be in W perp. Okay. 3. Let a generic element u be in W perp and c be a scalar. Okay, since W is in W perp, u times any vector from W is 0. Okay, for any vector W in W. Okay, to show C times U in W perp, we take CU dot inner product with W vector, and by one of the properties of inner product, this C can be taken out, U dot W. Now C U dot W is 0 because U is coming from W perp and W is coming from W. Okay, and this is 0, number 0, so a constant times 0 is 0. So this implies CU is also in W perp because CU times any vector in W is 0. So we showed all three conditions. Thus W perp is a subspace of Rn.